Get ready for the launch. We start with the Artemis 2 mission where the Orion capsule's heat shield was the star of the show. We are diving deep into the vivid details captured by NASA as the Orion capsule separated from its service module, revealing a surface so reflective it mirrored the Earth in stunning clarity. This mission was a monumental step, and we're showing you the high-definition footage that proves everything worked out perfectly as the crew safely splashed down. Essentially eliminating frustrating communication delays. We examine how this new radiation-hardened chip, developed through the high-performance spaceflight computing project, promises to give spacecraft the autonomy needed for missions to Mars. And finally, we wrap up with a major shift in how lunar science is managed. NASA has transferred the management of key lunar instruments to intuitive machines, with Mark Robinson and Prasun Mahanti taking the lead on the lunar reconnaissance, orbiter camera, and shadow cam. This move brings significant new expertise to the data collection for future Artemis missions. Don't miss a single update. Subscribe now and hit that notification bell so you are the first to know what's next. NASA has released stunning, high-definition footage showcasing the Orion capsule's heat shield during the Artemis 2 mission, highlighting its reflective surface. The heat shield, a critical component for crew safety during atmospheric re-entry, was a major focus of discussion for the mission. The new footage vividly captures the reflection of the service module on the capsule's mirror-like surface as Orion separated from it. This visual display has captivated audiences, revealing intricate details of both stages, including individual rivets. The mission, which launched on April 1 and included 4 astronauts on a 10-flight lunar orbit, concluded successfully with the crew splashing down in the Pacific Ocean. NASA officials shared the footage, labeling it a POV. You're coming home after a journey around the moon. The Artemis program, aimed at establishing a sustainable human presence on the moon, continues its progression. The next mission, Artemis 3, is targeted for late 2027, involving Orion's transit to low Earth orbit to rendezvous with lunar lander vehicles, paving the way for a crewed lunar landing during Artemis 4 in 2028. The mission media, including over 12,000 images taken by the astronauts, has been released since the crew's return. NASA researchers have unveiled surprising and dynamic patterns in Earth's artificial light through new, highly detailed maps, challenging previous assumptions about gradual changes in nighttime illumination. The findings, detailed in a recent study by an international team including scientists from the American Space Agency, utilize NASA's black marble data to reveal how human activity is rapidly reshaping the planet's nightscape. The black marble system, which tracks changes in human infrastructure driven by artificial light, employs the Visible Infrared Imaging Radiometry Suite, VIIRS, sensor on satellites like NOAA-20, NOAA-21, and Suomi NPP. This system captures light across multiple wavelengths, including green and near-infrared, providing unprecedented insight into nighttime activity. The new imagery highlights significant variations in brightness across densely populated regions, particularly between 60 degrees south and 70 degrees north. Areas that experienced substantial illumination between 2014 and 2022 were shown in yellow and gold tones, while regions experiencing dimming appeared purple. Researchers assert that these maps reveal that changes in light radiance are not simply gradual and unidirectional, but are surprisingly dynamic, characterized by frequent and coexisting brightening and dimming events. The team found that, on average, locations undergoing artificial light changes experienced 6.6 distinct shifts over the 9-year study period. Global radiance is estimated to have increased by 34%, though this surge in artificial lighting masked areas of significant dimming. The study identified distinct regional trends. The U.S. West Coast showed increased brightness proportional to population growth, while the East Coast exhibited dimming, linked to the adoption of energy-efficient LED lighting and economic shifts. Conversely, countries like the United Kingdom and France, particularly major cities like Paris, saw reduced light pollution due to conservation efforts. The sharpest overall decline in lighting was noted near the end of the study, coinciding with an energy crisis in several European nations following the invasion of Ukraine. These dynamic patterns underscore the multifaceted impact of human infrastructure on the Earth's environment, providing crucial data for research into light pollution, disaster impact, and energy infrastructure management. NASA is developing a revolutionary new processor that could enable deep space missions to operate autonomously, drastically reducing reliance on time-delayed communication from Earth. As part of the high-performance spaceflight computing (HPSC) project, this technology aims to allow spacecraft to make independent decisions during complex deep space operations. The new radiation-hardened chip is projected to deliver up to 100 times the computing power of current spaceflight hardware, with early tests indicating performance levels approximately 500 times greater than existing radiation-protected processors. Eugene Schwanbeck, a program manager at NASA Langley Research Center, described the system as a fault-tolerant, flexible, and extremely high-performing multi-core system. Spacecraft hardware faces extreme challenges, including intense electromagnetic radiation and significant temperature fluctuations from solar activity, which can cause errors in conventional systems. Engineers at NASA's Jet Propulsion Laboratory are subjecting the prototype to rigorous radiation, thermal, and shock tests to ensure reliability. Jim Butler, the project manager for high-performance space computing at JPL, emphasized the need for the chip to manage the unique demands of planetary landings without human intervention. This leap in autonomy raises significant considerations regarding risk, drawing parallels to cautionary tales like the computer HAL in 2001, A Space Odyssey. NASA envisions spacecraft capable of instant scientific data processing and immediate hazard response without waiting for ground control. While modern spacecraft utilize automation, this new technology introduces onboard artificial intelligence for mission-critical decisions. NASA is collaborating with microchip technology on sample chips for defense and commercial aerospace partners. The ultimate goal is to support crewed missions to the Moon and Mars, where communication delays make real-time human control impractical. The development pushes the boundaries of engineering, leaving open the question of whether these autonomous systems introduce unforeseen risks, despite the promising technological advancements. NASA has made a significant transfer of management for 2 key lunar science instruments to Intuitive Machines. This move is prompted by the joining of the instrument's principal investigators and science team members to the company. Intuitive Machines is now responsible for managing the Lunar Reconnaissance Orbiter camera, which is onboard NASA's Lunar Reconnaissance Orbiter, known as LRO. Additionally, Intuitive Machines has taken over management of ShadowCam, a NASA instrument aboard South Korea's Danuri orbiter, also referred to as the Korean Pathfinder Lunar Orbiter, KPLO. The Lunar Reconnaissance Orbiter has been orbiting the Moon since 2009, collecting vital data concerning lunar topography, composition, temperature, and the radiation environment. The Lunar Reconnaissance Orbiter camera is a sophisticated system comprising 3 cameras that captures both high-resolution black and white images and moderate-resolution multispectral images of the lunar surface. The instrument has accumulated over 1.8 petabytes of data, which is crucial for planning NASA's upcoming Artemis landed missions. Mark Robinson of Intuitive Machines serves as the principal investigator for the Lunar Reconnaissance Orbiter camera. ShadowCam is a build-to-print replica of the Lunar Reconnaissance Orbiter camera's narrow-angle camera, specifically engineered to capture high-resolution imagery of the moon's permanently shadowed regions, areas theorized to contain ice and volatile materials. Prasan Mahanti of Intuitive Machines is the principal investigator for ShadowCam. Both instruments were initially developed by Malin Space Science Systems in San Diego and were managed by Arizona State University in Tempe. Following this transition, the data management for both instruments has been consolidated, now being handled by Texas A&M University in College Station and integrated into NASA's planetary data system.